So let's talk about a case in which forces are acting on an object, but they are not parallel to each other. So we already discussed if we, for example, have an object. Let me have my best attempt to draw an object. So this is, for example, an object, right? And there are forces acting on this object. For example, a force of let's say 10 newton is acting in the rightward direction. So this is a force of 10 newton, and then I can draw another force probably in red color. Uh, or this is not red, or but this is a different color than blue, so it works. So this force is actually, for example, 5 newton, and it is actually acting not exactly parallel to it, right? So we can see that we cannot add these forces together because they are not parallel. So how do we find the resultant of these forces? And we have a video on that in the vector addition topic that actually talks about the parallelogram method. So we're going to talk about this parallelogram method. And so this video is basically a review of the parallelogram method, that how we can actually find the resultant of a couple of forces which are not parallel using the parallelogram method. So first of all, the first thing we need to do is to make the parallel vectors to the forces that are already here. So we can make a line that is parallel to this 5 Newton force, which precisely looks like this. And then we need to make a parallel force that is to the 10 Newton force, that is parallel to the 10 Newton force. So this is parallel to the 10 Newton force. And what do we get? We get a parallelogram, right? And then we just need to connect the diagonals of this parallelogram, which I can do it like that. So let me actually choose a nice decent color for that. So purple would do. So this would be the resultant of the two forces that are non-parallel to each other. So this force, for example, you can scale this down. So for example, this is actually 10 centimeters in length. This is 5 centimeters in length, and you can just calculate the length of this line using the scale, and then whatever the length of this is, for example, 13 centimeters or whatever, that is going to be the resultant of the two forces. So there are other methods to do that as well, but as long as your O-level syllabus is concerned, parallelogram method is a perfect technique to find the resultant of non-parallel forces. So you not only get the magnitude of the non-resultant force, but also the direction in which these two forces would be acting. So all you need to do is to create a parallelogram by drawing parallel vectors to the forces already provided, and then connect the diagonal, and you get a parallelogram. And then the diagonal would actually be giving you the direction of the forces in which they'll be acting, and also the length of the direction would actually give you the magnitude of the resultant forces.